So what we're going to do is each of our panelists is going to get roughly 5 minutes. I'm going to try and keep you to the 5 minutes. The thing that we want to achieve in that 5 minutes is to really understand who you are. So you obviously introduce yourself rather than just name it up and read your profiles. But also give us a little bit of a, when did you first encounter the term, infrastructure as code? Like, well, that's a weird term. Or, so cast your mind back. And really, what does it mean to you, right? And roughly, when did you start? So just that sort of idea about where you actually started in your journey on infrastructure as code. And I'm happy for you to say, I've been writing bash scripts for 28 years, and I've always done infrastructure as code. So we'll start with you.
Sure. Definitely not going to start off by saying I've been doing 28 years of bash. That would be fairly aggressive. So who am I to start with? My name's Dan Sowter. I work at Everyday Hero, the head of engineering. How do I get into this kind of stuff? I think the first kind of places I wish we were doing infrastructure as code would have been working in London. I did a bunch of different jobs around the different transit networks, so sort of London Underground, the DLR, that kind of stuff. And they were kind of classic engineering projects where we were doing, kind of change control boards and courts, and I think the way we provisioned infrastructure was by copying and pasting out of a Word doc, which I think is probably what happens right before this happens to a lot of people. That was sort of the glory old days, and then fast forward from there, I got into sort of web development side of things, so we're working in a small consultancy called NetEngine down in the valley. And then after a few years of doing that sort of thing and dipping our toes in a couple of different kind of technologies underpinning this sort of thing, we were always on the Amazon stack, a bit of Rackspace as well. And then in terms of working through the various tool sets that allow you to achieve this, we got into a little bit of Chef, how to crack a Puppet, eventually decided that Ansible was the one that made the most sense at the time, and kept pushing that. And I can talk through some of the different challenges we had at different toolings. And then when you fast forward into Everyday Hero, when I arrived about 9 months ago or so, these guys had been doing a couple of good years on Puppet, which is awesome. So I think the oldest things we had there were already on Puppet, which is really nice. And then we sort of had multiple Puppet generations for the various versions of the product, multiple generations of our products and infrastructure, everything from physicals to VMs to a little bit of stuff on Amazon. And I think you just started dipping your toes into Ansible when I first arrived. And since then, we've just mostly dismantled the old data center, mostly dismantled all the old Puppet projects, tried to push the knowledge out through the team on how to use Ansible, and then more recently push the knowledge out on how to put everything in Docker. So I guess what our infrastructure looks like these days, it gives you a teaser into our kind of general attitudes towards things. To give you an idea of scale, is probably useful in the beginning. We're a team of high 20s developers, something like that. Server-wise, I think we're probably paying for about 140, 150 servers right now, if you look between the different data centers and different accounts and things. What our kind of network looks like right now, the first couple of tiers, so kind of a web tier, is just all the routing and stuff, and the one behind it, the app tier, are both both stateless. Everything's running CoreOS. As a consequence of that, every single workload has to be in Docker. And that's had interesting ramifications for the way we think about this kind of problem. Then on the kind of tiers behind that and all the things that don't make sense to necessarily trust, or else things might have a little bit of state or be already solved problems. The Amazon Linux, where it kind of came to us out of the box for things like NATs, and I think security bastion, that kind of thing will be replaced by that soon. And then mostly try and use the managed services. We're strictly DevOps. You talked about the kind of cultural attitudes towards this in the company. Never had a breath of resistance against doing everything as DevOps. If I had any resistance at all, it might actually be from the dev engineering team saying, maybe hire a couple operations guys, you prick. We're full DevOps all the time. The way we try and make that happen is by having fewer stateful things to take care of. So that's why we've been leaning so hard on Amazon and trying to get rid of the things that could break. Is that what you think?
Perfect. Thanks.
Cool.
Hi, I'm Matt Jones. First time I heard of infrastructure as code was probably 4 or 5 years ago. But that started off as agile infrastructure, which kind of spun off onto DevOps. So we're here today. This is amazing. I run a meetup group in Melbourne called Infrastructure Coders, or Infracoders. I have a t-shirt, someone asked before. And we just care about infrastructure as code. That's all our meetup does. So it's basically the tool stuff people talk about in DevOps, but that's all we do. We don't talk about culture necessarily, just a ramification of tools. I've had pretty wide background in like government organisations, universities, startups, public companies, things like that. Solaris, OSX, which is both bad to manage as infrastructure as code. Windows, managed a few schools with Windows, which has its unique problems with Active Directory if you've ever used it. So you end up using batch scripts, not even bash scripts, to make your own client server so you can actually do infrastructure as code, because Active Directory is not so nice for that. But now I'm mostly in a Linux world. Used to do Puppet for, I don't know, 3 or 4 years, and now it's pretty much Docker. Similar story to Dan, where it's CoreOS, Amazon, Docker. But being with the Infracoders thing, which has some meetup groups around the world as well, and kind of keep your finger on the pulse of things like Ansible and SaltStack and other tools. So
I'm Dan Everton. I have been in many different industries, everything from a small startup where I was writing academics controls in Visual Basic 6, through to defense at Boeing, up to where my current position is a system architect at Expedia. I have not been at Expedia that long, actually. In fact, I don't really start until Monday. But acquisition of Wotif by Expedia, that's a good transition to a role with Expedia. I am a architect by trade, so I'm not super frontline, but keep an eye on the future stuff. Work with Matt on the continuous delivery team, DevOps role there. We started that sort of infrastructure as code stuff 5 years ago with a proof of concept between Chef and Puppet. We ended up picking Puppet. That's the right choice or not. And sort of grew the Puppet code base for managing the Wotif data center. Did more and more to the final stages where we had a fully automated delivery pipeline. Getting close to being fully automated. We've got more Expedia, so it's more relevant now. In the Expedia place, they have, since like August, only just started pushing AWS and DevOps type stuff, August last year. They have 1,000 AWS instances for a very small subset of their apps. They've got a data center in Arizona as well, and it's around the world. It's very fragmented, but the general push is AWS. Get there as quickly as possible. So their setup is Chef with which builds CloudFormation templates, which pushes, builds AMIs, and pushes them up with Jenkins. It's quite Rube Goldberg, but it works and it's quite fast. They're looking to make that more efficient. Docker is of course on the cards, but there are other things we're also potentially looking at, like Terraform for instead of CloudFormation, since it seems a bit nicer. And possibly into this sort of clustered compute Apache Mesos, DCOS type stuff, where we get more of a layer of interaction between infrastructure and the application deployment, which is obviously a very new space, but has a lot of potential.
Great. Well, I guess I'm a weirdo then, because I think the term didn't really exist when I started playing with Puppet. When Puppet was 0.25 or something when I started my family, and I'm still there. I watch it grow and do all the cool things it's done and can do. I'm also one of those strange people that also manage my Puppet server with Puppet, and I wrote a module to do it, and I published it, and a few other things. And what else? started the whole thing as kind of I wanted to be a programmer, and I sort of got through into the sysadmin land, and then discovered that I could program my servers, and I was very happy. And I've been there ever since. I work for myself. I had been automating myself out of a job for the previous 5 to 10 years. So I thought, stop this, I'm going to start a company and automate everything else and still have clients. And now I've got 2 clients who keep me too busy because I'm rebuilding their one of rebuilding an entire infrastructure of an ISP, which is kind of annoying. What else? I haven't played with Docker or anything else, but I've been using OpenStack quite a bit, but I've been probably doing it wrong, but I don't care. Well, the ultimate plan is to use Puppet images for OpenStack and then manage everything else with Puppet. But,
All right, thanks everyone for introducing yourselves. What I wanted to do is I know a few of you sort of touched on where you are now, but I kind of want to just dig into that a little bit more, just to kind of set the scene, because we'll then talk about if you're done or what's next and stuff. But just if you can stick to the question at the moment, like where you are now, right? And I think we can start with you, Dan, is in terms of, because it's kind of, you've done a whole bunch of work. Is it like ground zero? Like you're back to, like, so
it's, well, all the infrastructure we knew was gone, but it is still early days. There is a system in place for a subset.
So thinking about like Monday when you and the teams are all sort of turning up, so what does it look like? What is the...
So, as I said, it's a very new initiative, the AWS push for Expedia, and their attitude is get it done. Full steam ahead, damn the cost. Now they're starting to wind back and kind of go, this is costing a bit, let's have a look at how we can sort of make efficient use of that. So that's one of the focuses at the moment is how do we better manage the infrastructure so we know where the spend is going. They're not concerned about the actual spend, they're concerned about getting value from the spend. So obviously things like reserved instances, identifying who owns what, killing off dead instances and all that sort of stuff. Beyond that, they obviously want to move, they're not happy with the current chef setup, but they don't really know what the future looks like. It's sort of,
Let's just unpack that, right? Just so, so what do we want to sort of dig into? Like, what, some people might have heard the term chef, yes, sort of, some people may have, may or may not have used it. What, like, why, what's wrong with it?
I think it's not so much chef itself, it's that the thing with chef and Puppet, and I'm going to disagree with this, is that they are configuration management tools. Yeah, you can, I think you can push them to do manage infrastructure. And infrastructure can be considered configuration, but there does need to be, well, I think there should be a layer of interaction, I guess, between infrastructure and application deployment.
Puppet is lacking with the orchestration and stuff.
Yeah, that's probably the primary thing.
They're trying to access that with collective, but I don't know how close they are. And they want to do more. Recently they did a...
What was that? They haven't made a Puppet.
Puppet, as part of the thing they did, they wanted to know how people deploy stuff. So they're concerned with now actually trying to address the orchestration.
So orchestration is one of the trickiest bits of any of these tools. Neither Chef nor Puppet really deal with that super well.
They weren't really built for managing sets of things.
No, it's just managing, configure a single copy of something.
If you can kludge your way around.
Which is what we ended up with, or Matt built at Wotif, was a fabric to coordinate Puppet deploys. So I had Python configuring Ruby, which then ran bash scripts.
So I think you want to answer really publicly.
So, I mean, neither Chef nor Puppet has, at the moment, a good story around orchestration, and particularly for Puppet, it's difficult to say, you need to do this set of machines first.
Before you do it.
Yeah.
You can kind of do it, but you need to do some it's not
Yes.
and they do want to do this. They do want to do this.
I think that the Puppet Enterprise and everyone's Chef. They do want to, they're getting into that space because they can't be forced into it. Because everyone's kind of going, hey, orchestration, this is the big thing, we need to solve this now. And there is a few tools, I see CloudFormation and AWS. OpenStack has its own solution. Any of those. Which version of OpenStack? And obviously there's all the newer stuff like Deus and Flink as well in that space.
So let's, I guess, to sort of get some sort of circle back on this stuff, is really like, so is the problem that you're describing there is that it's not the fact that Chef describes things, because it's describing on an endpoint, but it's actually how that's applied to it.
Yeah, so we then end up using Jenkins to coordinate these things.
Right.
So Chef builds a template which then triggers a Jenkins build, which then has an agent in each AWS region to do the AMI build, which is then configured with Chef, and they push the AMI, and they do that for each region, and then there's, I think it's the Jenkins build then that changes the Route 53 weighting between the blue and the green deployment. So they've already got an orchestration tool, they're using Jenkins, but it's not really what Jenkins is very good at. Well, Jenkins is probably very good at much, but orchestration is.
It'll do stuff in order and tell you when it failed.
But there, I mean, even
It's not bad.
it's not super clear how the job relates to this. There's no sort of, ThoughtWorks obviously a solution.
We use that actually.
There you go. And obviously, CloudFormation is another solution. It gets. I don't think anybody's got it right yet, and a lot of the newer, really interesting tools are really early. I think in the days of Flink or Terraform or Atlas or any of the other ones that have actually hit even beta or alpha, they're still way below that.
But again, they're all different tools as well, different problem spaces. And the
Yes.
issue is someone goes, what we're using is horrible, let's use this tool. And they go and use it, and it works for that problem space, and they want to move up here. And they're like, let's munch something in to make it work, and they're using Jenkins to deploy shit.
Yes.
It's like everybody's decided to build their own like model RC car, right? And we're like, I'll have that fucking engine, I want a big battery, and and everybody's doing that, and there's no like really cohesive solution that I'm aware of. I mean, obviously, the ones you're talking to are probably the best bets right now. Yeah, exactly right. They're all heading in a direction that seems to be consistent with each other and seems to adhere to the kind of workflows and experiences we're starting to demand about these platforms we all keep building. But it's interesting, right? Like none of them is even remotely mature, and they all have these like kind of quirky implications for the way you think about your networks and the way you think about the life cycle of different things. I find that and then organizational implications are like the two most interesting things for me.
Yeah, which is, I mean, this goes back to, there's a layering question over, should there be one tool across all? Probably not, but where's the handover point?
Yep.
Which tools and what, and how do you coordinate between them?
Yeah, and how are you gonna like manage the risk of the fact that you've really got a different level of maturity in each tool to solve each problem space? So you'd be like, okay, I'm shopping. And you rock up and you go, I've got these 7 problems, and those 7 things might have a leader in each category, and some of them might appear in multiple categories, but certainly not as a leader across the bat. You know what I mean? And you say, I'm willing to give up this and that if I can have a little bit of consistency here and fuck consistency over here because it's terrible. You know what I mean? And you've got to do that. That's what happens right now. You learn enough about each tool to say, yes, no, maybe, 2 months commitment. That's all we can do.
And it gets worse, I mean, when you start talking about, well, now it's with Windows.
Yeah, right.
So, Expedia is a formerly Microsoft company, still lots of Windows, C++ code base. They're looking at Azure.
You can manage.
I know that you can, but they're looking at Azure, they've got other resources. So instead of being Docker, it's Docker.
Just Docker and Mono and make it look really cool in your head, and then just don't expect it to work.
But yeah, I mean, there are tools that solve this little portion over here, but the problem is a lot bigger. And
Matt, just talk a little bit about where you're at, sort of what does it look like when you turn up to work, and what are the sort of things that you're dealing with day to day at the moment?
Yep. So I work at the moment for a really small startup, and we're distributed around the world. I'm the only ops person so far. So my job is essentially to not do my job, it's to allow the developers to work whenever they want to work, however they want to work, kind of thing. And I create a path of, or hope to create a path of least resistance. Currently, our sort of bread and butter app is in Heroku, and I'm slowly teasing that out into Amazon, like fully managed by ourselves, apart from the infrastructure, physical infrastructure. That's got some unique challenges because if you've ever used Heroku, that's a platform as a service. It's got a Git endpoint. You just say, hey, run my code here, and it goes, okay, and does all the gem compilation and things like that, and just, here's an endpoint, put your browser at this, and bam, it works. So it's like magic to people that don't know what's happening behind the scenes. Sorry?
Heroku use AWS?
Yes, yeah, Heroku use AWS in the background. But again, usually people that use Heroku just as a Git push sort of endpoint don't really know that that's happening. So the unique challenges I have, it's like we're making some good sort of leadway of moving this stuff over, but constantly we have these, but it's so much slower than Heroku because we're not optimizing for thousands of customers, we're optimizing for one, and they do all these crazy optimization like pre-compiled gems ready to go and stuff like that.
So, is that what's the motivation for change?
Motivation is quite a few things. The startup we're at is in the medical space, so data sovereignty and data security and privacy is pretty important. Also just costs and the scale. We've kind of squeezed as much performance out of Heroku that we are happy to squeeze out. I think that the next step is for us to manage it ourselves so we can optimize interactions between different parts of the infrastructure. But yeah, mostly data security, sovereignty, and privacy, which is so being able to create a similar tool set to that sort of Heroku platform is challenging. We looked at DS and Flynn. That's two products that offer the similar thing where you just say, hey, run on Amazon, it spins up machines for you, and it gives you a Git endpoint where you just push the code, it's magic. But again, they make some assumptions about how you're going to be running your infrastructure, and it's those little quirky things that Dan's talking about is kind of good. Not that quirky.
Yeah. We can easily speak to that. We ran data in production for about 3 months to tide us over to wait for the rest of the kind of ecosystem to mature a little bit, mostly for our pre-production stuff. Exclusively for our pre-production stuff. But we learned what we liked about it, what we didn't like about it, what breaks all the time. We picked our favorite components that Dex was relying on, all that kind of stuff. Yeah. We can speak to a little bit about how that worked. We can talk more about how it looks today.
Yeah, let's talk about how it looks today.
Yeah, sure. Okay. So day to day, and the guys will call me out if we're relying on any sort of stuff right now. But we're in this constant state of motion, right? And I think that probably applies to a lot of us. But specifically, we're trying to, one, kill legacy data center. We're about 75% out of that. We'll be completely out by the end of the month. So there's a team of guys that are working exclusively on that. And that means about preparing those very old applications to sit on our kind of mainline current architecture, which we call Plain, platform lacking any interesting name. So Plain today looks like Docker containers on Core OS. It's static, so it's the compromise we decided to stick to while we wait for the next one, which we can also speak to. We've got decent progress into the kind of next one we're getting ready on. But Plain looks like Docker images pushed out by writing, not using any kind of centralized like fleet-wide scheduler, so we don't use Fleet, we don't use etcd. we write systemd files onto the hosts where we would like to run the job. We manage that with Ansible. So Ansible jumps onto each Boros node and says, touch a file, get it going, or write the environment variables that are suitable for that particular app because we've made a config change, which was also managed inside Ansible right now. So that's kind of what we're doing right now. Basically, it's like a static version of the thing we wish we had at DAS and Fling or Moodles.
So you're playing with your Docker images.
So we do follow a lot of the rogue mentality, so a lot of those terms are kind of relevant to the way we think about this stuff. So we say, like, a release is the code plus the config kind of thing. So if we're going to do a deploy, it's going to be because either someone made a change to the kind of configure repo, which is all our Ansible stuff, so they'll change the the token for a third-party service we're using in one of those in the vault, and then say, okay, it's time to deploy for that one. And they'll go and write a new environment variable that's sucked in by the Docker daemon on the system to unit file. And the other reason, of course, is that we've pushed a new version of the code, which means that we'll make sure the CI says that code's decent, rerun the Docker build, and then we'll push that to the thing and say, okay, tag it as the current one or whatever. I think that changes pretty frequently. And then run the Ansible playbook, and it tells the old ones to go and pull down the latest tag against the latest version they've got of the environment variables, and off to the races. Blue-green deploys and things are managed by just load balancing in the web tier and deploying some of the app tier nodes at a time. Certainly not a mature solution by any stretch, but that's the way we achieve it. Yeah, that's really the only rule we have right now is, while it's kind of all glued together with bubblegum and Ansible, just don't empty the load pool, please. But that's kind of what it looks like.
Maybe you want to pick one of your customers and sort of just dig in a little bit. So, like, what does it look like now? Don't you? Maybe from a perspective of because you touched on that you're really. I presume what you're doing is describing things that may have not been described. You may be going from like a Word doc or
at all.
Or at all.
Yeah.
Okay.
Running in VMware with basically managed with a bunch of shell scripts. And I'm basically rewriting the whole thing, updosing everything. Currently, sticking everything they've got into OpenStack. Because that's where they wanted to go, and I thought, well, okay, if it works, I want to play with OpenStack. Why not do that? It's not finished, but anything ever finished. But it's getting to the point where 90% of it is actually managed, and I can update versions and update stuff and update public code and everything else. Like pushing into production. I've got 2 Git repos, one for my public environment, which manages all the environments and the entire thing, and a higher repo, which I'm obsessive with sticking class variables for everything, and everything goes in higher. I use higher for MC. It works. But yeah, almost everything is there. I think that 2 things that aren't. But yeah. So it's getting to the point where I can go, oh, that works. What's next?
How did you build? Sorry, I'm hijacking. How did you go from effectively a VM that's running? It's essentially black box. You know what the outputs are. How did you know when you were good to go that what you've written in Puppet and deployed on OpenStack is going to be interchangeable without any issues?
It's a question. I generally try to use as much upstream stuff as I can find and make sure the configs work the same and test the shit out of it in Vagrant.
Yeah.
Basically.
Do you
I use
sorry.
the same code, the same environment code I use for my live environments on my Vagrant environment because it's the same.
It's the only way to manage it.
Oh yeah. There's no point otherwise. And yeah, I use the same Puppet module that I wrote to manage my Vagrant Puppet setup. So I deploy a Puppet master in my Vagrant environment and then deploy Vagrant nodes in that. do whatever, getting by our customer or both. So I think it's the sheet tested out before it came along.
So I guess what I'm hearing is this, reasonable level of maturity in terms of describing the nodes. Just from most of you is in terms of like what things do. You know what they do. You're trying to describe them. But now it sounds like more. Is it an optimization, or are you just not happy with the state? So like now, what I want you to sort of pick apart is more like think of all the different things that you've clearly done lots of different things. But like, what's wrong with it? As in, like, so you've all got different perspective on, like what's wrong with the current, view of it. So what I want you to, be honest about is why do you think that it's, not ideal yet?
I think a couple of things are not ideal here, right? I think finding the appropriate balance between when you allow a change and when you start fresh is a really tricky one. At every layer, do you know what I mean? If you're in Amazon land, do you make a new VPC on every single deploy? Do you know what I mean? Like, no, seriously. Like, so this is the question. Like, at what layer, do you decide to tear it all down and make a new one, compare, round robin, whatever it is that you like to do on a deploy? And I think that decision then has implications for what your whole tool chain will look like. How hard you invest in CloudFormation or Terraform or whatever you've chosen for that particular part of the program. So that you've got to make some decisions. I don't love where we are with that. I think that that whole config drift kind of thing that people were really worried about managing with tools like Puppet and Chef and that was the focus of that generation of tooling.
Accessible managing everything.
Exactly
So
right.
there's no conflict to it, I know exactly what's on it.
Sure, okay, but this is it, right? So when you think about config drift on an individual node, you're implying that you ever modify it. Yeah. So the question is, how far do you go down that immutability thing on your whole platform? Yeah.
No, it's not immutable. If anything changes, I don't change it. I need to update stuff. I need to roll out a new version if it's updated on the thing. It's fine.
Well, no, that's fine, but what I'm saying is like that decision, that conversation, and that interest in that part of the tooling implies that you ever change something. Because if you take away that focus, right, and you go just at a node level in the first place, I only deploy new nodes and execute old ones, then you stop worrying about config drift, and you don't care about most of that ever again.
Yeah, I'm still deciding whether, I'm trying to extract, I stick the data over there, I stick the stuff that isn't data in something that I can throw away if I need to. If I need to.
Absolutely, and we do the same thing. So like that's one of the very first steps we took. So we'll just segregate the stateful and stateless things from each other, like worlds apart.
Stick important data in volumes and deploy volumes. Whatever it is.
That's right, and because of the implications for the life cycle of those stateful versus stateless systems, you make decisions and think about where your risks are and how you're going to choose to manage those things.
I'm still trying to work out how to escape from MySQL and PHP.
So how much does that question change depending on how close you are to production, between development and test environments and
That's interesting.
into production?
I think you change more aggressively on staging, to be honest. I mean, we certainly wish. I know we test a lot of things in production where you feel like it's going to take you forever to capture data. So like, if you want to, we test things in production, and I never mean code, but infrastructure stuff, that happens. Like, you have no idea if your web config's any good, if you're not slamming quite a lot of traffic at it. Everybody's got different makeshift solutions for that kind of problem. And then, you look at your your security groups and things like that. Yeah, it's okay to test them in a staging environment. If you are managing, that particular part of your network layer in code right now, you can easily roll that out in different places. But should we all be in that spot where we just can't possibly imagine how we're going to test this into that production? And so that happens. But on the lifecycle stuff, yeah, like no one's going to call you and wake you up if you break staging most of the time. Depends. With developers outside the world, and they do, which is very frustrating. But they you feel okay about building your VPC from scratch every time in staging. On production, you're probably going to miss that hand-rolled that somebody made to a VPC pairing thing because of a migration between your old system and your new system. There's those kind of little funky things that sink in over time. And that's the config drift problem at the outside layer of the thing. So yeah, we change less frequently in production on the network, so that somewhat is hand-rolled. We land in this thing, and we're suddenly able to use the tools to describe what we have now, and then roll that back into our next provisioning step. So like the current state of production suddenly informs what we're doing staging. but I'd be lying if I said we built it from scratch with the tooling because it takes me fucking long. Have you ever tried to write a cloud formation thing from hand? Did you give up?
I think you've got to think of it in a physical kind of way as well. That even like it's amazing that we can rebuild effectively what was a data center 5 years ago with a bit of config and a tool like Terraform or CloudFormation or something like that if you're using Amazon. But we also did the same things. You would maybe redeploy on a new physical server. It's just that same upside down pyramid. You wouldn't change data centers every deploy. That's just not realistic. So we still have that physical mentality applied to virtual infrastructure, if that makes sense. And we're only just starting to sort of let go and realise that it is just code now. So we can do that if we want to. Sorry?
Yeah,
I think so.
That's
Matrix.
That's an interesting question. I don't know if it's going to be on your list or not. You can't cheat sheet ahead there.
Can you redeploy everything by cleaning a couple of Git repos and pushing them up from people and all that? Can you do that?
Well, the way I was going to spin the same question is like, how do you find the commercial and risk balance between, like, when does it stop being the lowest fruit? You know, like when is it worth your time to invest in that thing that, as you point out, you could change every single time if you want to be a superhero on Amazon, or you could keep using the same VPC for many years and none of your customers would know the difference. So, how do you hedge your bets? How do you invest? What are you giving up? If your attitude is code through, what do I now have that you don't? That's the question, right? That's what it looks like. So, I mean, I'm interested to see how you guys make those decisions.
Yeah, well, I think that gets into the question of like, the answer is usually immutability, but at what level? And like, yeah, sure, your AMI is your BMDK, whatever, it's immutable, it doesn't change. But it's part of an auto scale group. Well, yes, you do. I mean, like, once it's deployed, it doesn't change. If you're upgrading OS, you're deploying new image. Well, that's the idea, but it's part of an auto-scaling group. So there's state, and it's inside. It's got security groups, and there's state there. So the infrastructure has bits that can be immutable, bits that aren't, and yeah, that's kind of gets to the heart of why it's so hard to build a tool, find a tool to manage this well, because the trade-off is different. Like, yes, destroying a VPC and recreating it each time works unless you've got like 1,000 instances of VPC. It's going to take a while.
Yeah, fair enough.
That's one of the big challenges that I've had in the current position and previous positions as well, isn't configuration management. I think that's solved. Like, there's so many ways of doing that. There's some pretty good tools out there that can do that for you. It's orchestration, and I think everyone sucks at it so far. And as a result, a lot of places I've been in, someone hand rolls something in Jenkins or Capistrano or whatever.
But I don't think we'd be the only gang having a crack at it.
Can I ask you a question? How would you define that difference between the two in terms of the guts of it?
Yep.
Between
So
config management and infrastructure?
yeah, so I think of configuration management as a single entity, and you're saying what should this entity be represented as?
So like a service.
Sorry.
Or a service or a web service.
Yeah, correct.
Yeah.
And then orchestration is how do these services
Talk to each other.
interact with each other. So if we want to look at sort of configuration management is it's single entity. You can pluck it out. It could be someone could go on there and run around and they have no idea about any other services. Orchestration says, right, you need this version on that machine and that now needs to talk to this database.
The orchestration is how you make it actually happen.
Yeah, it's
So you might-
plugging everything in.
Exactly. So you might just to make another way of saying, you might think of configuration management as of a service which might either be a container or a node, right? And then your orchestration is the configuration of the whole system. Yeah.
And the order is implied, which is
Yes.
some of the hardware.
Sure. Yeah.
Well, if you have to order it,
We're really bad at creating race
Yes, you do.
conditions as humans, and then when we give it to a computer, we find all these race conditions, and we're like, sleep.
It's so silly.
Now, how do you actually look at Terraform code and how it deploys instances of stuff? It's like, call that API and just sit there polling it.
Yeah,
So Terraform, if people don't know what it is, it's a third-party tool by a company called HashiCorp. It's open source and it interacts with CloudFormation, which builds Amazon services.
I was directly to these
There we go.
and GC
Packer and
Vagrant, and they have their own solution orchestration. Atlas.
Yeah, yeah.
It's now their pay tool, so that's HashiCorp. That's one to sort of.
Collecting all the cards.
If you look at that's the progression, here's your immutable server. Okay, you build the packet. Okay, now you want to test it. Well, hey, here's Vagrant to do that for you. Oh, you want to do service discovery and coordination. Hey, here's
Packer
Console.
came out after Bacon.
Well, obviously, yes. But you can see that there's a story that they're working through. They've got Terraform for deploying infrastructure, and they've got Atlas for coordinating Terraform deploys and deploying it. So,
I don't really need to perform there and stuff.
no, but use it to test
Can
it.
I don't want to.
So just, we started getting a little bit sort of into the immutability question, right? Is that always going to be, like, I think you're starting to ask that question, like, is that app dependent? Like, or like, where are we going to make those decisions? Because, like, you kind of touched on it, like, are you looking after a single application, or are you looking at tens of applications?
Yeah.
Like thousands of, like, how different is it? Like, how many different types, if we just touch on it, and we touched on which is sort of a summary, like, how many types of applications are you looking at?
Okay. Yeah.
I think it depends on the application as well.
Well, I think you've got to look at your whole system because they're going to have really different attitudes on how it's going to work.
Things aren't actually immutable.
Your database is not immutable.
Oh, yours isn't? Yeah, look,
You
it's,
certainly need to increase your how much memory you would, because your devs decide to just stick in giant blobs and then fucking code.
yeah.
What do you do then?
I think the immutability thing depends on depends on how decoupled your teams are to begin with. Because if you've got, depends how far you are on the kind of other road that everyone is having in the background. Like this is the ops conversation everyone's having right now, and the dev question everyone's having right now is about what the fuck is a microservice. Yeah.
The book is coming out in March, I think.
Yeah,
Tell us.
I think we've got the pre-release right now. But I think what I'm going with for that is, if you haven't decided how you're going to handle communication within your organization for microservices, you might want to deploy it and leave it up as you deploy future versions. Like that's one massive tick on the immutability box. If you say, like to the application that's running right now, the service you depend upon, its load balancer maybe or whatever it is over there, will never change, it's always on that port, stay there forever. When you deploy a new one and you're saying that wants to communicate with a new one, it goes and faces that, right? So then you would have in parallel every version of your microservice. And I think, I could be wrong if someone's worked there, but I'm pretty sure that's how Netflix does it. But you might not be able to afford that in your organization, And then that decision might then have implications that immutability no longer makes sense at a server level because you're not at that kind of scale where you can afford to leave everything up once you've started. So you're going to then go, okay, I'm going to give up immutability at the node, so that I can kill the old version of the service to make enough RAM available to deploy my new version of the service. And then you're immutable at the service level, but not at the host level. And I think there's a version of that decision with those kind of trade-offs at each level.
I think, there's a whole bunch of industry trends sort of heading kind of in the same direction. There's the microservices discussion. There's Heroku kind of pushed that 12-factor app stuff. There's the rise of self-contained apps, the Drop Wizard, Spring Boot, all that sort of stuff. And obviously Docker. It's starting to push the app. Hey, we were doing this back in the JWE era by deploying ears to clusters of containers, but anyway, what's old is new again. That direction is that the application itself is becoming self-contained and relying completely on the infrastructure to be configured around it. And we can only really do that now. We couldn't super it on physical infrastructure. We can do that now because we can query the infrastructure and say, hey, what state are you in? We need to turn you into this state. Oh, okay, now I know what the change is.
Dear platform, where's my database?
Yeah. And then we get into the software-defined networking sort of thing.
That scares them. It does.
Yeah. I think everybody's got a good solution for that,
How many bad networking units?
Alright, so then I guess what I wanted to do then is really obviously was talk a little bit about where you are now. And obviously the next question is like you know, is your desired state no IT all undone? You know, but, you know, we're clearly all in this, you know.
Drop mic.
But you know, like, what do you feel like it looks like? I mean, don't start picking tools that don't exist or even just nascent tools. So forget the tooling. I guess, what does it look like to you know?
Interact with it.
Yeah.
Yeah. Like if we got really lucky, how far in the future are we allowed to pretend this is? No, I'm not going to give you a dumb answer, but like, you know, like where I want to be in 3 months and where I want to be in 2 years is pretty different, right? Who knows what AWS Lambda is? Yeah. Okay, so the basic premise of AWS Lambda is forget about the underlying infrastructure. That's it. That's the promise. It says, give us a function and tell us when you'd like us to run it. Yeah. We'll figure out a way to charge you that has some resemblance of what hardware used to look like back in those hardware days. But basically, you never talk about a host, you never talk about a service, you never talk about deploy, you don't do any of that stuff. You just say, have some JavaScript, run it when this happens, see you around. Yeah? I would like to see that attitude applied to the rest of the services I'm trying to deploy. Yeah? And I think that is the same, like if you think that it's back to today, that's what it looks like to look at you know, data center level kind of, I don't care what host I'm running on kind of solutions, which is the kind of promise of a lot of the schedulers. Yeah, even if you're still picking a distribution. And if you go like a little bit forward from that, you know, you look at the kind of data center OS solutions out there that say, yeah, you're right, we don't actually need to worry about what the distributor is anymore. Yeah, it's like, I like that line of thinking. I think that's really attractive.
The resource model.
Yeah, exactly. Yeah, there's just the work unit model. You know, dear cloud, have some work. Yeah.
So what level of you know, DevOps-ness, if you like, do you want that to lie out? Yeah. Because of course you've got the system, you've got the platform that it all lives on. But what you're talking about is total disconnection from that platform. And I don't know if you were hardware IT in your past or whatever.
Yeah,
or you were just,
that was originally hardware.
yeah. So there's got to be a level of DevOps at some level down there to give you Lambda. So that's how do you deal with that?
Okay. Yeah. Well.
No,
No,
but someone has to.
No, you're absolutely right. Okay, so like the way I just described that, I just described that with my dev hat on. So I'm sorry.
But it's the same. It's a utility model. You go to the tap, you turn the tap on, water comes out. You don't care that there's a man down the street, you know, fixing a pump, sort of thing. You just expect it to happen. When it doesn't happen, you call someone angry. Like, what is it?
Yeah, exactly. That's totally true. I mean, we could talk about what I think the engineers are doing that build that, and like, you know, what decisions we've had to what we've had to give up to reach that kind of place. It's interesting you said the what is old is new again kind of stuff. Who's in love with static binaries again, like static linking? Yeah, static linking and unikernels and simplicity. Fucking disk space is pretty cheap these days. You know, like maybe just don't worry about sharing dependencies anymore, and we'll all just get rid of the hell for it. You know, a couple of those kind of compromises I think are going to go a long way to that platform we're all talking about. You know, getting rid of the whole threshold style analysis of is something working, just starting to do anomaly detection, and when it moves outside of some boundaries, you just kill it. I think that would make those guys' lives a hell of a lot easier. You know, it's these kind of attitudes. You piece them all together, and eventually those guys have got less to do.
Yeah.
You know, one of them's going to be replaced by the robot that goes around and plugs in a new hard drive.
Yeah.
You know?
There's actually a paper, Quasar paper, talking about, I don't know if, so the data center OS and scheduler stuff, there's a few projects, there's one from Twitter called Mesos, which is sort of what they describe as a kernel for the data center. So it manages your hardware and says, it presents you a cluster of 10, 12 core machines. Here's 120 cores.
Yeah.
And you just deploy schedule thing on it and say, well, this app needs 2 cores, this app needs 4 cores and stuff. And it's, yeah, and the abstraction is basically the devs now just ask for some fraction of CPU count and memory. You don't have to do that, they just say, just submit a call to a service and it does it. So all of Twitter runs on that. It takes care of, oh, you want 3 instances? Oh, go over here, and if one of those machines dies, well, it's just going to start up somewhere else. And I think Facebook has taken that to the extreme where, you know, a whole rack can die, or they want to scale out, or they just wheel a rack, pre-configured in, plug it in, and it self-configures and joins the cluster. Not going to get to that stage.
Yeah, immutability of racks, by the way, is this cool thing I've been reading about. The Facebook guys do it and the Amazon guys do it. They actually just use shipping containers, and they put just enough ventilation for like, not for humans, but exclusively for the machines. They only put obviously like fanless machines in there, right? And it just has a power outlet on the side. That's it, they wheel it in, plug in a power outlet, and when enough of inside is dead, they get rid of it.
Microsoft's going the same way.
Yeah, amazing.
So once you get to this sort of software level, you know, developers are saying, oh, I need 4 cores and 1 gig, then you can start looking at the feedback. So this Quasar paper looked at, I think the numbers were something like data centers see maybe at best 30% utilization of the resources available. So the Quasar paper looked at, so what if we looked at how they actually behaved, what their resource requirements actually were, and then fed that back into the system, and they ended up getting up to either 60 or 85% better, you know, utilization of data center resources. So that's sort of the future, is the software starts going back in on itself and self-tuning and stuff. We're obviously not there yet, but that, I think,
Pretty attractive.
yeah. And it takes some of the guesswork out of, well, I don't know how many cores. When you deploy a new service, I don't know, 6 instances, 2 cores, I don't know, just deploy it. You know, those sort of, as soon as you make your infrastructure an API that can now program infrastructure, that can apply all of that machine learning, all that AI, all that computer science stuff to the infrastructure, which is scary as hell, but you know, it's going to bring some powerful stuff.
I got a question, but is there a question thing at the end?
Yeah, I've got one more, and then we'll open up for questions. if it's great, go.
It's not relevant to what's being said here, but it's obviously it's about.
So, my last question is kind of where I thought we would get to, which is like, sounds complex again. Like, you know, like you all just described simplicity, but as soon as you start digging into the simplicity, it's starting to get, you know, like somewhat. So, personally, how are you thinking about managing complexity? You know, because are you just trying to, you know, like build complex systems or build simple systems or layers?
Yeah, absolutely right. Yeah. Unskinny stuff. Yeah, looking for the simple option in each possible slot and saying, I'm willing to give up this much to use that simple tool, please. That's what we've been trying to do recently. You know, like you look at something like CloudFormation, you go, man, it's not simple at all, not simple on anything, but a bit of bash around the AWS CLI tool starts to look pretty simple again. You know, or you know, the static binary thing. You know, you go, fuck, it's hard work getting these Docker images down to a thin enough size to push and pull them around, or yeah, I'm really happy that I'm finally deploying it, but now my updating, like when a patch comes out kind of thing, it just starts to look like insanity. You go, hey, I've got immutable services over there, fantastic, I'm gonna leave that running forever. But the distro that was like the first set of files put as the base layer on the Docker thing has got a horrible vulnerability in it. That's not what simplicity looks like. Simplicity looks like static binaries and BusyBox. Yeah. But that's it, right? So like, even if they sound like these complicated ideas and stuff, the execution is actually just to give up a couple of things. You know? So if you go, well, maybe you're right. I actually don't need to install the whole fucking universe on my node before I can go hello world with my favorite high-level language. Give up a little bit, make it easy for the ops guys, but you start spending a little bit less time there. You get a little bit more time you're now spending on the other thing that you're willing to give up, or the tool that makes it a little bit less painful. But it's simplicity on the knowledge thing, right? It's not simplicity on how the meal puts together. You know, we didn't go backwards in time. Like, it's the demands of the customers and the workloads and all sorts of stuff are only like exponentially skyrocketing.
You can't take that away.
Exactly.
It's never gonna go away.
Yeah, you don't get to play an easier game. Yeah, you just have to figure out how you can. Yeah, it's more sense. You know, it's like
When you destroy the first customer and get a new one.
Beautiful customers, yeah.
Yeah. Are you bigger than my previous customer? Yeah. But that's my answer. Just keep it simple in people's heads in terms of one thing they have to do.
Well, I think part of it is also that it's kind of inverting, like, the operating system. What does that do anymore for your app and stuff? It gets obviously you need a couple of file
It
systems.
makes it possible to get something that's your whatever thing you
Do I need?
I know, yeah, it'd be great.
Yeah. Do I process one, only on the app on this box. Yeah, I don't know if anybody's actually heard of the unikernel concept, which is basically combining the kernel and the app into a single deliverable.
Not JVM.
It's kind of in that space, but it's more like we combine kernel, the app, and drivers, and that's what you deploy as a single OS, which just happens. Right?
Sounds like embedded systems.
So JVM.
Well, but the JVM is itself standalone, and you deploy the app. You don't usually get the JVM inside the app. So that's easy.
The monitor program that used to run on like PDPs
And that's the thing, I was like, the mainframe and Solaris people are probably just going, why is this here like in the 70s?
But you know, the rules have changed. You know. That was a good answer, and then there was a better answer for the systems and hardware and problems we had, and now the problems look different. Like shit, that old answer is pretty cool.
But it was good technology at the wrong time.
Yes.
That's why they went bankrupt.
Well, it was
And
really
then
good.
it's like,
Exactly. Here's a big question that you guys might be able to answer. Why the fuck does SQL still exist then?
Well, because my version answer would be the knowledge thing. You know, like if we can't invent ways to understand how to get stuff back out of a database as fast as we invent databases right now. So SQL's a great way of going, you know what, Dudu used to have a job, still a job.
I think that's going to Unity and COBOL, just so we have a job for the next 20 years.
I just think you were saying, you know, what's this, do you want to be complex or simple? At the end of the day, we're working in a job, whether you want to get paid or not is your own answer. But you're trying to deliver, presumably, a product to someone, and you work with other people. And essentially, that is what, as operations, DevOps, dev people, you're providing that to someone. And we can talk about unikernels and stuff like that. But at the end of the day, we want to make our job simpler, not the infrastructure. I don't give a shit if it's really complex. If my job's easier, that is awesome. And provided someone else can come along and doesn't think it's complex too, that's what I want to get to. So someone can walk in and understand it. Like, what's the internet thing? Explain it to me like a 5-year-old sort of thing. Like, I want infrastructure to be that. So you can explain it to someone and they're like, I get this.
Yeah, not 3 days of like drawing on the corners.
Yeah,
Like
yeah.
nightmarish.
Here's a
Here's
slide
a
deck.
mouse, here's a click.
Because ultimately we want to spend less time on our app. Do you know what I mean? Like they use this kind of runway metaphor all the time in startups, but it applies to every company, right? Just stop fucking around on the things your customer doesn't care about, and then go build the stuff they want. That's what we're trying to do, right? That's what simple gives us.
Make the smart stuff in.
Yeah, just, you know,
It also looks complex now because it's still very early days and the answers haven't shaken out yet. We still don't know what the final thing's going to look like. In 2 years, 5 years, this is just going to be a checkbox in your AWS console and say, Lambda is getting pretty damn close to just like, I don't care, just deploy the app and answer requests, whatever it costs me, networking, whatever.
I think it's that machine feedback loop is the juiciest part of it, right? Because it gets rid of so many other things. Like I just don't really care about my init process on a box anymore because I don't give a shit what processes are running. If I don't have enough throughput on high-level services, the customer sees it, build more of them. Fine, whatever. Yeah.
I've heard of a concept that someone was talking about with Lambda as well, where you don't actually deploy code to a server anymore. You deploy it, and the next request that comes in actually fetches that code and runs it instantly.
Yeah.
So you're not deploying anymore. You just here's a new script to run, and it will only deploy when someone's requested it. Which that's pretty crazy.
That is crazy.
On that question of simple versus complex manner, I like your answer. It's what people find simple. I'm interested in, depending on what people do, will be depending on how they find it simple or not. Like, it's easy for a sysadmin to go onto a box and manage a box with a bunch of applications. That's what they're used to doing. It's easy to create a Docker image and just deploy that, and that's your one image. So depending on where you are up to a sysadmin, that might seem complex because they don't understand a lot more than just the box. But when it comes to something like upgrading the JDK that sits under your app, it's simple for a Docker image. You just change the layer and rebuild it. You go into a box, you've got to change the JDK because of all of the apps on there. So what was simple at one stage is now complex to us. What was complex to one person is now simple to us. What do you think of the balance of simple and complex depending on who you are and what you do, the context of the environment.
I think that's where I've seen a big adoption of Docker and sort of before Docker Ansible as well in the config management space, because it removed that DSL and it removed, you know, knowing Ruby's ins and outs sort of thing. And if you wanted to copy pasta something from Stack Overflow and jam it in a playbook, it works. Someone might look at it and their eyes bleed, but it works. So that's, I think I'd much rather have something in and working if someone else has done it, and then later on you can go and explain the complexity behind that probably shouldn't do it that way because that's not good. And they learn your knowledge rather than you sitting there, you know, banging your drum saying, no, you need to do it this way, knowing the complexity, but they don't. So I think, yeah, getting the functionality out there, or feature, or whatever you want to call it, I think is more important than how we get there, because we can have that conversation retrospectively. Because if you do it once and no one ever looks at that, let's say for the Ansible case, no one looks at that playbook again, who cares?
That's exactly it, right? So there's a really good expression for that. How many of you guys, anyone else is a Ruby guy, or is it strictly Armstrong? Like Sandy Metz, is anything anybody? Yeah, okay. So there's a principle, obviously everyone knows there's the regular kind of object orientation principles, so I'm pushing the devs one you might. But there's this one phrase that Sandy Metz coined 2 years ago, which is amazing. It's saying you want to have, like, you know, simplicity everywhere, right? All we're really doing with what we're doing in DevOps right now, and what we're doing in our applications like pushing microservices, shoveling the complexity around. Yeah, we're giving up complexity somewhere we're looking at in exchange for moving it elsewhere, and that's might look like we're just, you know, protect Titanic stuff, right? But then there's this concept of the omega mess. You know, it's okay to make a mess if it's the last thing in the line. You know? And it works. Genuinely works. You know, you could, you know, if it's in your code, you can have like this horrifying class that talks to the database and knows everything about happening behind it, and then you put an abstraction in front of it, and then that thing's ridiculously easy to use. That's kind of what we're doing right now. We're pushing app problems into ops, and pushing ops problems into tooling. That's what we're doing, is shoveling around the mess, but eventually it's going to end up in the ones that day to day we don't use very often. You know, it's going to take an awful lot of work to make the tools smart enough to get rid of the problems, but we're doing it. Yeah, and eventually we're not going to read the source code of all the tools over and over again. We'll just play with that nice interface.
Well, it used to be the people who used to read their operators.
Exactly. Like this is every tool we talked about today does that for us, right? We don't worry about how the hell you turn on a VM and a network in Amazon. We just use the Amazon API. Yeah. This is what we're doing. Creating mega messes, moving the complexity around until we don't have to look at that anymore.
And we've also got capability, if you really want to get to this level, of looking at your code base for your application and also infrastructure and working out what do we touch the most. Let's simplify that part because we use that the most. So if we want someone, you know, new hire to come in and just, you know, smash it on day one, let's make that part so simple. And then, like you were saying, get the broom out and shove it under the rug. Because they might touch that another 6 months, 12 months,
yeah,
never.
Exactly.
Who cares?
And you know, this is the DevOps thing, right? And this is another classic developer conversation. You know, you separate things that change at different rates. It's like day one in software development. Now we're doing it in infrastructure.
Yeah, it's kind of, I had this sort of conversation in my, subconsciously in my head. I was thinking about my company.
Right.
And then I worked out that basically everything I do all day is abstracting it. So I abstract my team. So, well, that's basically everything. I make a layer on all the thing and to join it there.
I think that's
Even all the stuff that I use, even the upstream stuff I use, I can see it does this and kind of get with the full lines public code.
All right, conscious of time, I'm going to open up to questions. I mean, I have more questions, but I think it would be far better if some of you have sort of got these little things bubbling around you want to ask. Either ask someone specifically, or, you know, feel free to
Can I do that?
you guys can just have a discussion.
I got one. You guys have all variously just described some extremely sophisticated setups that you guys have come to understand over a period of many years, which I think is fantastic. At the other end of the spectrum is where you drop into a place and they show you a wiki of some kind, which may or may not exist, which has some documentation about some stuff, And
For operating
it's,
systems at 6 years old.
yeah, it's literally, it's day one, and you know that the intent is we want to make things repeatable, say at least. So what's the order of business for what's the low hanging fruit when you're going from unmanaged to managed?
Would be best to ask on that.
Yeah, the thing, the best way that I've discovered that this is what everyone seems to think, is you pick the thing that takes you the longest and automate that.
Yeah. Automate yourself.
Yeah, too. Well, I used to call myself sysadmin. No, I don't. That's my public service. It's my sysad.
So really it's a time and motion study in a sense, because what you're talking about is the things which are most time consuming, which prevent me from actually doing the things like maybe optimizing or thinking strategically about where we want to head. Like if I get rid of the ones which are reproducible but are time consuming, that's the low hanging fruit in that situation.
Yeah.
To me, provided you do them often enough. If there's a task the data center's been hit by a plane, you need to rebuild the data center. Don't optimize that. Optimize the long, usually deploys is a massive thing that people jump straight into, because you do that often. Most people do.
Or you're testing or other sorts of stuff.
Yeah.
Yeah.
Or in some cases, the things that are just causing pain and interruptions.
Yeah, like users.
Password resets are often ones. You can find a way that's acceptable to a business to automate password resets.
So an interesting.
So you get an automation, you get an authentication system, stick it somewhere else, and have the user control which passwords they put in.
Yeah.
So an interesting way of if you really are, greenfields in the sense of having things automated. I've found in some places, if they don't have very good monitoring infrastructure set up, set that up first, because then you have a bit better idea of like black box.
The closest you can get to infrastructure unit tests.
Yes. Yeah.
Before you refactor it.
Yeah.
Yes.
So that way you don't have 100% confidence, because if you have no idea what the service is on the inside, but you have confidence that it worked before and it still works according to the monitoring and interactions. There's always quirks there.
Yeah, I tend to automate my monitoring as well. So every department, it's got a service, it's got data, it's got apps, it's got monitoring, it's all in there. So I think, shove it on there, does that 6 modules now.
Matt was actually giving a presentation. The other approach is to basically sort of say, well, that's the current state. Find a component you can then say, look, we're going to go and try and build that the new shiny way. And then once you've worked your way through that, people will hopefully see that it's so much better and start saying, well, okay, can I have that for my system? Can I have that for my system? So you slowly build the infrastructure in the new way. Yeah, you might suffer from second system effect and all that sort of like, oh, we're going to do this, we're going to do this, and it's all cool. That's always going to be a problem, but if you can manage it, building up a second sort of stack for just the newer systems, and this is kind of the approach Expedia second with AWS. It's like, yep, data center stays there, we're going to build new apps over here.
And all the cool kids are over here.
Yeah,
so
and you want to be a cool kid, right?
but it's a doing process. Like if you've automated that giant thing, pick the next biggest thing, automate that. And everything is automated, and then you're under the pump.
Yeah.
Our next question.
Mine wasn't a question, but going back to you, is to break it up and to go back to what Dan was saying, is to find which bits of that are the Omega mess and put them aside, because no one's going to be worried about that.
Right.
It works, and hopefully you don't have to touch it again.
Mm.
And the idea with the Omega mess is that when stuff in there isn't affected by stuff elsewhere, and there's no dependencies in or out, so it becomes self-contained. You just leave it until someone has to touch it.
There's a similar pattern in the microservices space in dev, where Mark Fowler talks about the strangler effect. You just put microservices around the crappy thing in the middle until that falls away and dies. Yeah, well, it's the same with infrastructure. You try and make other things better and more manageable and things like that.
So just hang on a second, okay.
Network infrastructure as code. How's the experience been on your various platforms? Are you still handling most of the network as you balance it and attaching services to it? What are you doing?
Well, obviously AWS, everything is software defined.
But are you defining it as as code, or are you setting up the AWS subnets and stuff by hand and deploying into that?
No, they're all set up. They're all configured in the Chef repo. So this app is part of a security group. This app, these security groups deployed. Other security groups defined in this manner. When we do a deploy, security groups updated with changes.
Our version is different to that. We made it by hand because of the ridiculously aggressive timelines. And what we find is, because you've got the last API, it's not just for creating, right? So you roll it by hand until you're really happy with how it looks, pull it down, and then you use that for creating the next one. You don't have to do it as code the first time anymore on that sort of thing.
Because you can query the state of it.
Yeah.
Automating it after the fact is much more feasible. I mean, if you have to put a whole bunch of Cisco switches, what the config is, it's a lot harder, but you can still probably pull config out of iOS and turn that back into some recipe to automate.
In the physical world, it's very difficult. Very, very difficult. I think Puppet had a Cisco module, still does.
It does have one. I haven't used it. But ISP, most clients in ISP use Cisco Kit. Randomly suggesting you should use Puppet.
Just referring back to Ansible though, that you can just give it something and it'll go and do it. So if you've ever used, or I had Cisco networking background and did stuff over SSH and then dropped to the iOS. So you can just plug all that stuff into Ansible and say, do this, do that, and it will just go and do it. So Ansible's not really doing it. You're just, here are the commands, do them on that path, thank you.
At least you won't mistype them every second time you go around.
Yeah, exactly. I was going to say, like that's just the other kind of counterpoint what we were saying before about isolating things with abstractions and that sort of thing. Is don't go nuts. You know what I mean? Please stop writing modules in Ansible and things like that that do something that a perfectly good CLI already does today. We're wasting each other's time. You know what I mean? And then we're like, no, I want to do it the Ansible pure way and use the module that does AWS. You're killing everyone. You know what I mean? Like these CLIs exist. Pick the abstraction that makes sense. As long as it's going to be actually.
As long as it's repeatable.
Yeah, exactly. Right.
If it's repeatable first, then.
Because it's the brain space. It's the simplest you want to get, right? Do you want to learn the new DSL to the thing you already know? Yeah. Or do you want to actually, jump out to shell and use CLI?
If you've got budget to go buy a whole bunch of new equipment, I think Arista has a whole bunch of switches that support SDN. So hey, there's an option.
So just a question.
Yeah, you asked that question about the what do you do when you go in and just attempt to automate something from scratch. So what is the first thing that you guys do? Do you just jump in and start coding, or do you actually sit down and document what you've got? How do you plan it?
Depends on the environment and the company. So
well, in this case, we're talking hardware, like a server environment, a server infrastructure environment.
But it depends on the support you have from the business, because we've operated the ones where cloud is a dirty word. We'll never do it too expensive. And it helps people not happy with cloud either. So that's not what we can do on the physical infrastructure.
Yeah.
And that's fine. Sorry?
Build their own cloud.
Well, it's just, and they started hitting it out. But the other way is just saying, well, yeah, you've got Shell, you've got SSH, you can go a very long way with that, as long as you keep to some standards.
But how do you actually, like from an overview of the system, how do you guys start? So you're saying that you jump in straight away and start coding the whole thing without looking at the full environment from top down, or?
Well, this is what we just did every day here. Like, I arrived when you guys were exclusively in Indigo. You had some stuff for you to love, some that you didn't love, and it's kind of what we said for the demand, right? It's like you do the motion study on the whole system. Yeah. So depending on what your business is, right? Depending on how the applications and things compose, you might go, this thing I have to deploy every 6 months. These ones that deploy every 6 months. These databases have actually not been touched for this long. You figure out how many they're wise.
Yeah.
And then you go, actually, okay, the future stuff over here needs to be deployable continuously 30 times a day would be great. Yeah. So you go, okay, well, I'm going to end up wasting more time on the 30 times a day kind of things. Build a happy place for them from scratch. Yeah. And you just gradually make that kind of new thing more and more attractive to legacy stuff continuously. Yeah. That's what we do.
Usually the easiest one is cross-cutting concerns. could start with things like, well, okay, we want to be able to monitor all of this, no matter what it's measure it,
Yeah.
build that up, collect the Grafana or whatever, build those systems, then start going, okay, now I need to put the agent on all the boxes. So those sort of cross-cutting things are probably the easiest place to start, and also get ops on board with automation. The experience I've had is that a lot of the operational people can be very hesitant to automate stuff, because obviously the single button that then deploys to 100 servers is scary as hell if you don't trust them. You've got to build that trust up. So you do one server, let's do 10, and let's do, and then actually trust them.
I tend to break it up into things, like a bit of an ASAP looking at it, and I tend to go and find public code that's not a Go wrote, and find out if it does a vaguely easy job. If it does, I tend to use it and fix it for it and not send it patches. Or if it doesn't, I write my own and publish that.
Alright, a couple more questions?
Just quickly on that point, sorry, just for getting the trust up in the tooling, the config management tooling. If you're used to managing stuff by hand, installing stuff by hand, you don't trust public, you don't trust chat. A tip I've heard from Mr. Sadmin is I write my Puppet module and then I go and do it all by hand. After I run it in no-op mode to see what's it going to do, I go and do that by hand. Then I run in no-op mode to see what's the diff, and I go and do it by hand. I do exactly the Puppet module and I update them one by one. And I keep running in no-op mode until it's all green, it's not going to do anything. And I know it's not going to do anything. What it would have done is exactly what I did. So I know my module's good, and then I run it in full no-op mode, what's called in Puppet, and it should do nothing. So build up the trust by incrementally doing
All you
it.
run
corollary
is
to that
tests for all your code first.
Tests as well.
It's then run the code.
Yeah.
The corollary to that is in things like Ansible, where you don't actually have an alt mode. You just spin up nodes with your recipe and see if they behave the same way as
Alongside.
divisions.
Well, you touched on the other thing. None of these problems exist in isolation, right? You're not going to do any of this unless you've got monitoring. You're not going to be able to do any of this unless you've got tests. You're not going to be able to do any of this unless you've got organizational support. Like this, let's not pretend we're on our own over here with this problem.
Yeah, on the back.
So, yeah, I'm talking about taking legacy stuff and building it up and making it new. What if you want to start from something new? How do you start small and scale it up and not face roadblocks when you're scaling up? As far as your infrastructure is concerned. So I want to set up a simple website, do simple stuff, but obviously it's like the idea is to set up a startup, but it has to scale really fast. So how do you go about doing that?
Use Heroku until you can't afford it.
Yeah.
Seriously, use Heroku until you can't afford it.
Heroku has its problems, but it is kind of, it's one of the, if you looked at it in an abstract level, it's kind of perfect solution. It's like, I don't care, just deploy and scale. I don't.
Be mega mess.
Yeah.
That's it. All that, no ops. That's it.
Yeah.
Use Heroku. And if you're making enough money to justify building a system, spend some of that money.
Yes.
That's actually my story. The company I worked for 3 years. One person that started this company, and their Heroku, and their bill just kept getting exponentially larger until they're like, we can hire someone to make this go down.
Like Netflix have exactly the same problem, at a different scale. In their case, they go, well, for most of our business logic servers, there's no point in us going and building servers or anything like that, so they use AWS. But then for their content servers, they go build their own devices and deploy them into data centers. And at some point, they're going to get big enough that they're going to go, well, screw it, we'll build our own data centers.
I suppose that's probably one of the fundamental questions is when does, because it sounds like three of you guys are using AWS exclusively, or going to be exclusively. When do you get to the point where you say, wow, AWS is costing me $1 million a year for something that I could pay for $1 million for that infrastructure, which will last 3 years or whatever?
So I've got two hesitations with AWS. One is their location. So in my case, we'll have data sovereignty and privacy issues with governments and states around the world. That is coming really soon. So all the stuff we built in mind that we're probably going to have to run this on hardware in the future. So that needs to be a little bit agnostic. And the second thing is, as much as I love AWS, I think we as an industry need to be really careful about syncing all our shit into AWS. Do you remember all the vendor lock-in from all the things we were going away from? We're just doing that again.
Mainframe.
Yeah.
All those people still want you to be locked in.
Yeah. So, I don't know, give Google Cloud and Rackspace and DigitalOcean some love.
I mean, that's the other one, the software is really interesting. One day, it's not so much virtual infrastructure, physical stuff. So you get bare metal hardware, but with a configurable interface. And obviously, private or hybrid clouds is another way to sort of either dip your toe in the water or sort of come back from.
You can actually, Miraculous has a hosted OpenStack. Because ridiculous amounts of money.
All right, we're going to wrap up. Is there any other burning question before we wrap up? All right. Thank you to our panelists. I really appreciate